Okay, so in this video we're going to look at the sample, still looking at the sample exam, and we're going to do the uh, area, volume, mean and RMS question, the little integration applications question. Okay, so again I give you a copy of this in web courses, so you'll have the exam paper in front of you, the sample one. Now, just go over the question. Right, so okay, you can kind of see the pattern from it's the same every time: area, volume, mean, and RMS. So the area ones and the mean ones, are the area and the mean are not too bad. The volume and the RMS ones are just they're a little bit problematic, because you have to remember that well, you don't see the volume formula. This is the volume formulas in the logs tables. But both of them involve y squared, the function squared. So you have to square that function before you integrate it. Right, so we'll see that now when we reach those questions, but we'll just start up on it. Okay then, so the area, out of all of four of them, the area is the one that's sort of not given to you, because it's expected that you know that the area under a function, the area it's expected that you know that the integral of a function with limits in it represents area. Right, so find the area enclosed between that curve and the x-axis from 1 to 2. So all we're looking for here is you to integrate that function between 1 and 2. That's what area stands for. That's maybe an oversimplistic way to say it, but the question's been designed so that there's an area underneath the curve, so it's not quite always that way. But as far as you're concerned, you can assume that that's what's going on. Right. So well, the little formula is, if you wanted a formula for it, it would be the integral from a to b of the function y dx. Right, so for this question, again, I might just take my off the screen there. The area was x, or this function was x4 plus 3x plus 11, and it would the limits from 1 to 2. So I'm integrating from 1 to 2, 1 to 2, sorry, x4 plus 3x plus 11. X to the 4 plus 3x plus 11 dx. Okay then, so as I said, area and mean are the nicer formulas out of all the four, because you don't have to square them. You don't have to square the function y. You just immediately start integrating. So without delay, you start attacking that fella. So there's no thought. You don't have to think about anything here. You just go straight to it. So it's ready to integrate. It's all x to powers. There's nothing to think about. So I'm about to integrate. So because there's limits in it, I surround the answer to the integration in square brackets. I put my little limits up there, and I'm about to now integrate. Okay, so it's x to the power becomes it's x to the power plus 1 divided by the new power, the power plus 1, or in other words, it's up to power divided by the new power. For this case, is x to the 5 over 5. Never those little numbers out in front, don't worry about those. That's plus 3. We're so used to that when we're differentiating and integrating. It's just 3 x squared over 2. The y is at x squared because there's a little invisible 1 up there. That's why, so the 1, so bump it up and divide by that new power. Bump it up by 1, divide by the new power. Over 2. Again, this a warning has to come with this here, and the warning is the integral of a number dx equals the number x. The number with an x on it. Because why you'd ask? Well, because differentiation is the opposite of integration. If I differentiate a number times x, you're left with a number. But anyway, so the integral of 11 is 11x. And what I'll do is I'll surround the x with a little bracket, because then it'll make it clear as day then when I'm subbing the limits in later what I should be doing. Okay, so what I do now is I say, well, I need to sub 2 into all of that and take off what I get when I sub 1 into all of that. So but I need to be careful with all these plus and minuses and all these values. So what I'll do is I'll put the answer to what I get when I sub 2 into it there, and take off the answer what I get when I sub in 1 into it over there. Right, so I'm about to sub in 2 and all of that, so I'll take my time. If you want to just sub 2 into it in the calculator, that's fine, but I'm going to get 2 to the 5 over 5 plus 3, 2 squared over 2 plus 11 times 2. And over another bracket I'm going to get 1 to the 5 over 5. Again, you'll know, if you know that's 1, that's fine, but 1 squared over 2 plus 11 times 1, which is going to be 1 and 11 anyway. Right, either way, I'm ready to go with the calculator. Right, so 2 up to the, 2 up to the 5, move out of that over 5, plus 3 bracket fraction 2 up to the 2 divided by 2, close that, plus 11 over 2. Equals, so I get 172 over 5 the first time, so I'll get I'll keep that in there as well, 172 over 5, back the bracket again, back to, where am I, back to the calculator again. Right, you could easily maybe just change them to 1 with the delete button on your cursor there. Probably faster for me to do it. I can do this on the keyboard on the screen here, but anyway, that's so. But you don't have to do the whole thing again. 127 over 10. 127 over 10. Finally, take one away from the other, and be careful. See, if there was a minus there, minus by minus is a plus. So that's why I'm kind of making a big deal about surrounding them with brackets before you're ready to go. Right. So I've it just kind of looks funny there. 172 over 5 minus 127 over 5 for 10. Yeah, 217 over 10. 217 over 10. Now just go back up and ask or check what the question asked you about your answer. It said, where am I? It said, the question said, find the area enclosed to 1 decimal place. So I'll round this thing to 1 decimal place. Let's see what we got. There's a change button on the Sharp calculators and the Casio. You have that there, and it was to. There is no. I don't have to think about anything. The answer can be written as it only has 1 decimal place there anyway. So it's 21.7 equals 21.7. So just wrap it up and say therefore the area is 21.7. Right, the next one. I'll take it down with me. Just going to take it down here. Copy, paste. Here we go. Find the volume again. We kind of find the volume of the solid revolution formed by rotating the function. There's my function y equal to 5x plus 2, and there's my limits 1 and 3. Right, the formula for this is in the logs tables. Check it out. What page is it? I'm not sure. I wrote it up in class when we were doing a revision class on the revision Thursday during the revision week. I told you what page it was on, but I can't remember now. You'll get the logs tables in the exam. Not 100% sure what page they're on, but the formula goes like this. V, it's in the logs tables. V equals, this is the way it's written, A to B. Pi y squared. Right, so the first thing I would do with that formula is take, pi is just a number, and we can always take numbers outside the integral symbols. We can always ignore them when we're integrating them. They're pi by whatever you're integrating, so I'm just really integrating y is the function squared dx. Right, so the huge issue here is that the big thing to remember is you will need to square the function y before you integrate it. You don't integrate first, square second, because some people were doing that in the class test. Anyway, right, sub all in. My pi stays outside. My limits were 1 and 3, so I put a 1 there and a 3 there, and my function was 5x plus 2, but I must be careful to square the thing before I integrate it. Right. Okay, what do you mean square it? I mean multiply that bracket by itself. Multiply it by itself. 3 by a 1, multiply it by itself. 5x plus, first of all write it down beside itself before you think of squaring it. dx. Right, I get, so it's first by first, first by second, plus second by first, second by second. Use a different colour there maybe. Blue, back to blue again. That 2 by that 5x and the 2 by the 2. Right, so take your time, just do it right. Equals pi. Still, again, I'm taking that integration symbol with me on every line because I'm not ready to integrate yet. I'm just doing a bit of algebra within the inside. 5x by 5x is 25x squared, plus 5x by 2, that'll give me a 10x, plus, we'll change colour maybe, plus 2 by 5x is a 10x again, plus 2 by 2 is a 4. Right. When you square brackets with two terms inside them, it's no coincidence that that's going to happen, that they match up. Not that, well, yeah, that they're identical. So you can, before you integrate, to make life easier for yourself just later on, without having to integrate four terms and subbing in numbers into four terms, add them up and say 10 apples and 10 apples, or 20 apples. 1, 2, 25x squared plus 20x plus 4 dx. Right, now I'm good to go. I don't have to worry about anything. They're just all, it's a sum of x's to powers. So away you go and start integrating. Right, just be careful that pi will stay outside. Because you're now about to integrate and there's limits, change that to a square bracket and close it over here and put your limits up above, as we were kind of used to doing in class. Start attacking this thing. Numbers in the front, don't get worried about them, just keep them outside a bracket, and within the bracket integrate x squared, and it's up to power divided by the new power. Again, in case you're asking, why, because the logs table says, it's in the logs table, so I'm not it's too late to be worried about that now. Anyway, 20 by x squared over 2 plus, again, number, the integral of a number is 4 as 4, the number times x. I'll go back to that point. I mean, at this stage you really should know that, but x to the power, when I integrate that, the rule in the logs table says it's x to the n plus 1 divided by n plus 1. This is where the sen comes from. Up the power, bump the power up by 1 and divide by the new power. That's where that's coming from. Okay. Right, start going with that then. Okay, so start subbing stuff in. To the 2 will go, put the 2 in and take off what you get when you put the 1 in. Be careful, there's a pi on the outside of the whole thing. So pi will multiplies the entire answer to all of this business, if you want to put it like that, of putting in the 2 and then putting in the 1. So I'll open up a big bracket, and within that bracket I'll put in the 2 and then put in the 1. Right, let's put in the 2 first. I mean, if you want to manually put in the 2 and then go to the calculator, I'm just going to go to the calculator. Right, so I've typed what I see, I'm still in the calculator, so 25 bracket fraction 2 cubed, the sharps don't have that cubed button, 3 plus 20, what happened there, sorry, I cleared the screen, plus 20, 2 squared bracket 2, get out of that, plus 4 bracket 2. Okay, equals 344 over 3. Just go back and edit your numbers now using the cursor button. See there, back, delete button. See it, yeah. 1, back. Press delete button. 1, back. Delete button 1. Hit enter or hit equals 67 over 3. Go back now, type the whole thing in. Now, just be careful that this question asks us for put your answer, express your answer in terms of pi. in terms of pi. I rubbed it out, sorry, I scribbled out over it. So don't worry about the pi, just evaluate those numbers and keep the pi in your answer. Right, so the numbers are 344 over 3 minus 67 over 3. 277 over 3. So with I'll keep the pi outside, and in the brackets 277 over 3. Right, and what I'll just do, that's not going to end up as a nice thing. You didn't have to, if it does it turn to a nice decimal place? Right, what you don't see there is that dot means that 3 is repeating, and it displays that when you press that one more time. So it never ends, so let's just leave it like that there. So 277 over 3 will do, lovely. 277 over 3. I don't mean leave it like that there, I mean we always usually write pi at the end. Therefore, V for volume equals 277 over 3 pi square. Put a little square around that there. Finally, the mean and RMS question. I'll take it down. 2 seconds. Okay, there we go. Take it down here to the end. Right. Determine the mean and RMS values of that function there. That function there from those limits 0 to 2, and your formulas will always be given on the exam paper there, so that's fine. So the only one you have to hunt for, or go on a hunt for, is the volume formula, but the area is just that's what when you integrate a function between the limits, it stands for area. Okay, right, so we'll do there's not a part 1 and part 2 to this, so just put a nice structure in your answer. Say, right, and find the mean first. I'll put a box around it to say this is the mean section. Yeah. Okay, so look at how it uses y bar there. So we'll just use y bar equals 1 over the top limit. This is your b, that's your a, from 2. So 1 over 2 minus 0 by the integral from 0 to 2 of y itself. So like the area, it's just a y in the formula, but the volume and RMS have this y squared, so it makes the question seem a bit more difficult. Okay, so the y is just x squared minus 9x dx. Right, no, don't have to square anything, hop right into the integration. So it's a half on the outside, square brackets, 0, 2, and start directly integrating. Right, there's no number in the front I have to worry about, so it's just x cubed over 3. That minus 9 stays, leave it alone, and say that the integral of x is x squared over 2. Again, because there's a number, that half in the front doesn't mean it's what I'm trying to say is why do I put this big bracket? Because this is wrong. If you just multiply what you get when you sub in the top limit by a half on its own, that would be wrong. And what you have to do is it's a half by all of this business of putting in the top and bottom limit. Right, over the calc. 2 cubed fraction 3, get out of the fraction, minus 9 bracket 2 squared fraction 2, get out of the fraction, close that, equals minus 46 over 3. There was a 0 going into this. I mean, if you can't see it, go to the calculator if you have to, but 0 into both of those becomes 0. Okay, and then finally type the whole thing in while you're at it. So 1 over 2 minus 46 over 3 minus 23, and again, if you had to put in a 0 there, that's fine, then equals minus 23 over 3. We'll just double check what it said about decimal places. Correct 2 decimal places. Okay, so let's turn that to a decimal. Again, the change button, you have a change button on a sharp calculator. I have a repeated decimal there. Press it one more time to make it display, because of that dot there means 6 repeats endlessly. So to two decimal places, go out to the third one. So again, I'll just maybe to highlight all of that. Let's take a picture of that. New, 2 seconds, sorry. Okay. Right, here I go, get my pen. Right, so to go to two decimal places, you don't stop at the second one and you look out to the third one. Is it 5 or more? It is. So you bump the second decimal place up by 1. So I get minus 7.67. So therefore, the mean, which they put a symbol in the question of what they called it y bar equals minus 7.67. Right, finally, RMS. Let's take the formula down. It's this function's the same. It's still x squared minus 9 x, and the limits are the same. So it's just a formula. It's a different formula for RMS. RMS RMS equals the square root of, so it's it's the most awkward if you want to put it like that, formula to work with, 1 over b minus a to the, from integral from a to b of your function y, but the function squared dx, so you have to square your expression for y. Okay, so that's a square root of, put everything in, if you can remember, or I'll go back up the question again. What I should have done was just take the question down and get one more time again. And I'll just sort of pop it up, and I'll just sort of pop it up there. There we go. Right, so functions x squared minus 9x, but my limits are top limit 2, bottom limit 0. The b is 2 for b, 0 for a. 1 over 2 minus 0, but the integral of 0 to 2 of the expression squared. So put it in a bracket, x squared minus 9x, and we're squaring it now in 2 seconds, dx. Okay, so while I'm at this question, ran out of space, funnily enough, just 2 seconds, I need to move the page down a bit. Sorry about this. Okay, back in again. Right, so while I'm sort of working with this expression, all the time I have to keep taking this. Nothing happens at square root until the very end. There's a half. And again, because with volume and RMS formulas, you square first, then you integrate then. Right, so I have to keep taking, nothing happens, the integration symbol is still there. Okay, start squaring that fella. So if you want to write them beside each other, write them beside itself first. Repeat. Dx. Okay, x squared. First by first, first by second, then second by first, second by second. Be careful of all those minuses there. Right. Okay, so we'll say that's the square root of a half by, still not ready to integrate yet, so this stays exactly where it is. You're not integrating here, you're just multiplying out brackets. X squared by x squared. When you multiply x, the powers together, you add the powers. So it's x to the 4. X squared by minus 9x. There's an invisible 1 there. So 2 plus 1 is a 3. So that's why I'm going to get minus 9x cubed. Again, there's no coincidence that this will be exactly the same, minus 9x cubed. Minus by minus is a plus. Again, if you want to just be careful, if you have to do it like this, minus 9 by minus 9, carry on. I get 81, but there's no sign there, so it's a plus 81. X by x is x squared. Extend that out, that doesn't end, it's square root of the entire thing, dx. Right, it's again, just put them together to make life easier for yourself later a little bit, equals square root of, again, all these guys are staying a half of 0 to x to the 4 minus 18 x cubed plus 81x squared dx. Right, once you have that thing squared and cleaned up, in all cases then, all cases mean volume and RMS. In both cases, now you're ready to integrate. Okay, but what feels kind of weird or odd is that you're integrating within the square root symbol. Okay, a half, nothing happens that yet. I'm ready to integrate. They become square brackets, 0, 2, and start your integration business. Okay, that becomes x to the 5 over 5. Leave the constant outside, minus 18, x to the 4 over 4, plus 81 x cubed over 3. Right, sure, if you want to just go to the calculator now, but what I'll do is I'll say, so it's the square root again, so this does not leave until the very end. So all the problems are rolled into one. It's like the RMS is each question rolled into one, because you've the number out in front. Anyway, you have the square, the function first before you integrate. Anyway, half of all of this here, and within that there's my little square brackets where I pop in each of my little answers. Right, okay, put in the 2 first. 2 to the power of, see, I have no up to the 5 button in both calculators, so I'll just do 2 to the 5, get out of that there, fraction 5, minus 18 fraction, 18 bracket, 2 to the 4, get out of it, fraction 4, bracket, plus 81 by bracket 2 up to the 2 cubed, fraction 3. Get out of that bottom and up to the top line, and close that fraction, equals 752 over 5. Go back now and just edit, go back, take the cursor back and change the 2's to 1's. Oh well, we have a 0, so that was fine, we didn't need to do that. 0 and all of that, like before, good stuff, it all becomes 0. Right, in a way you could just, you're left with just numbers, so you could just type what you see again in the calculator. So what do I see? I see the square root, I see a half, I see a bracket, and I see within that bracket the whole. But if you're being technical, I suppose I see. But anyway, I think you get it. 752 over 5. Close the bracket once and twice. No, close the bracket once, and your equals. It's set to 2 decimal places. Right, third decimal place is 1. It stays, so it's 8.67. Equals 8.67. So therefore RMS equals 8.67. There's a little square around the whole thing. Thank you for that.